This is for Year 12 Methods. It comes out of 2019 VCAA Exam 1, question number 9. So this is F, and this is G, and I've got to put F inside of G. So this is going to equal F inside of G, e to the 3 plus 2x minus x squared. Find the values of x for which the derivative is negative. So the derivative of this, so d dx of g of f of x is going to equal the derivative of an exponential is this, and then the derivative of the inside is minus 2x plus 2. So where is that going to be less than 0? Well, it's only going to be less than 0 because this thing here will never be 0, always going to be positive. So when this is negative, so minus 2x plus 2 being less than 0, so minus 2x being less than negative 2, x being bigger than 1. If x is bigger than 1, then that's going to be negative. State the rule for f of g of x. So I'm putting g inside of f, so f of g of x will equal 3 plus 2 lots of e to the x minus e to the x squared. Okay, so f of g of x, which is what this is, equals 0. So I can recognize that as being a squint quadratic. So if I let a equal e to the x, I've actually got 0 equals 3 plus 2a minus a squared, which is the same as a squared minus 2a minus 3. A, 3, 1, negative on the 3. Therefore, a equals 3 or a equals 1, which means e to the x equals 3. So x equals log base e of 3. Or e to the x equals negative 1, and that's not possible. So that's where that equals 0. Coordinates of the stationary point of f of g of x. So f of g of x equals 3 plus 2e to the x minus e to the 2x. I'm looking for the derivative. So f dash of g of x equals 2e to the x minus 2e to the 2x. If I set that equal to 0 and take a 2e to the x out as a common factor, I've got 1 minus e to the x. That can't be 0, that can't be 0. 1 minus e to the x equals 0, when e to the x equals 1, and x equals log base e of 1, or x equals 0. Coordinates of the stationary point. So the y coordinate will be 3 plus 2e to the 0 is 2, minus e to the 0 is 1. That's going to be 4. So 0 and 4. And lastly, the number of solutions. Okay, everything that's happened prior will assist me to do the last question. So f of g of x is all the stuff in black. G of f of x is up the top. So if I'm going to make these added to each other, I'll get a 0 when it crosses the x-axis. So what do I know? I know that g of f of x is an exponential. It's always positive, has an asymptote at y equals 0. And I know that the derivative is negative when x is bigger than 1. Therefore, the derivative is positive less than 1. So I'll use red for, it's always, so here's 1. It will come down and it will go that way. And at 1, it's going to be a stationary point. Why do I know that? I know that it is always positive because an exponential can never equal 0 or be negative unless it's been translated down. And it's only got a negative derivative when x is bigger than 1. So it's asymptotic and asymptotic, and there's only one stationary point. Here it is here at x equals 1. So that's what that's going to look like. So this one is always positive. So to add to this to get a 0, then the other one's got to be below the x-axis. So what about the other one? This other one is equal to 0 at log base e of 3. So I know that at log base e of 3, it cuts the axis. What else do I know? I know that it has a stationary point at 0, 4. And there's only one stationary point. Therefore, at 0, 4 has a turning point, which means it must go down like this, and this must go back down, but it only has one x-intercept, there it is there, and it only has one stationary point, so this must stay as positive. So any addition of these two curves has to be up here, and it can never cut the x-axis. There's only going to be one time that the addition of these two things is going to cut through the x-axis, will be only once. So therefore, the number of solutions is 1.